Good morning, students. Today we are starting with chapter 2nd of class 11th chemistry, that is structure of atom. In this chapter we will be studying in detail about atom, the discovery of atom, the various subatomic particles present in the atom, the structure of atom as was given earlier and what it is now. The whole of the history of atom till the present form we will be doing in this chapter. Now atom, the existence of atom was first told to us by the Indian and Greek philosophers way back in 400 BC. The Indian and the Greek philosophers said that matter can be subdivided again and again until we get the smallest particle which cannot be further subdivided. That smallest particle was called as Parmanu by the Indian philosophers, and the Greek philosophers gave it the name atom. The word atom has been derived from the Greek word atomio, means uncuttable. So when matter is subdivided into smaller and smaller particles, finally the smallest particle which cannot be further subdivided was named as Parmanu and atom respectively by Indian and Greek philosophers. Now, later on, as the science progressed, the scientists came to know that atom is formed up of many subatomic particles. Atom can be further divided and it is made up of many subatomic particles. Although the three main subatomic particles are electron, proton and neutron. These are the three main subatomic particles. Although at present we know a large number of other subatomic particles like neutrinos, positrons, mesons, etc. But the most important are these three: electron, proton and neutron. So now we will be starting with the discovery how these subatomic particles were discovered. First subatomic particle to be discovered was electron. So we start with the discovery of electron. In 1850, many scientists including Faraday was studying the electrical discharge through gases. And they used a specially designed tube which is called as the cathode ray discharge tube. Now this discharge tube consists of a hard glass tube fitted with two metal electrodes which are connected to a source of high voltage. This is negatively charged, the cathode. This is positively charged, connected to the positive terminal of the battery. It is the anode. And this tube is also connected to a vacuum pump which can reduce the pressure inside. Now, many experiments were done by different scientists, including Faraday, Julius Plucker, Hittorf, different scientists. And what they found, that at very low pressure as low as 10 to the power minus 2 atmosphere, Normal pressure is 1 atmosphere and we are taking the pressure 0.01 atmosphere. At very low pressure and at high voltage, a voltage of nearly 10,000 volts was applied, then the walls of this discharge tube start glowing with a faint greenish glow. Again I am repeating, it was seen that at very low pressure, nearly 10 to the power -2 atmosphere, when a very high voltage of 10,000 volts was applied, the walls of the discharge tube started glowing with a faint greenish glow. Now, the scientist got interested in studying what was happening. So, by performing a series of experiments by different scientists, they found that there were certain rays which were coming from cathode and they were moving towards anode. And these rays travel in a straight line from cathode to anode. Now, different scientists carried out different experiments. One of them took anode as perforated. Perforated anode means anode having small holes. And the space behind the anode was coated with zinc sulfide. Zinc sulfide has got the property of phosphorescence or fluorescence. What do we mean by it? If anything strikes zinc sulfide, a glow is produced, a greenish glow is produced, a flash of light. So zinc sulfide is a fluorescent material, and if anything collides with it, a glow is produced. So it was seen that the cathode rays pass through these and a greenish glow, a fluorescence of phosphorescence was produced. This helped us to know the first property of cathode rays. Cathode rays travel in a straight line from cathode to anode. We can say the first property, cathode rays travel in straight line from cathode to anode. Now, certain other experiments were done to find out the properties of these rays. Since these rays were coming from cathode, they were called as cathode rays. Why the name cathode rays was given? Because they come from cathode. It was seen that when an electric field was applied, this is the electric field that was applied. That means I can consider this is the tube, this is cathode, this is anode, and we have applied an electric field here. Now, it was seen when the electric field was applied, the cathode rays were deviated towards the positive plate, and here the fluorescence was produced. So, on applying electric field, cathode rays were deviated towards positive terminal. Showing that it is negatively charged. Showing that it is negatively charged. That's why they are deviated towards the positive terminal. Now, another experiment was done. Instead of electric field, when I apply a magnetic field, A magnetic field means this is the tube and I put a magnet. Here it is the North Pole and at the back it will be the South Pole. So this is how you are putting a magnet, North Pole and South Pole. Then it was observed that the cathode rays were deviated in the direction expected for any negatively charged particle. Where we expect the negative charged particle to deviate, in the same direction cathode rays also deviated, further proving that they are negatively charged. So we can say the third thing that was observed was on applying magnetic field, cathode rays were deviated in the direction expected for negatively charged particles. So this was the third experiment that was done. Another experiment that was done was a very light pedal wheel was placed in the path of the cathode rays. A very light pedal wheel made up of very thin film of metal. And what was seen? This light pedal wheel rotated. This proved that cathode rays are made up of material particles. You can just imagine in the fair, when you go to some fair, there are certain paper fans mounted on a stick, and when wind is blowing, they start rotating. In the wind, there are small sand dust particles, and when dust particles collide with this fan starts rotating. Same way, this light pedal wheel started rotating, showing that cathode rays were made up of some material particles. So we can say the next property is when a light pedal wheel was placed in the path of cathode rays, it rotated, showing that cathode rays are made of material particles. And of course, these particles were negatively charged. Now, what was done? The material of this cathode was changed. The metal of which cathode was made was changed. The gas inside the discharge tube was changed. Even on changing the material of this cathode, changing the gas, the properties of the cathode rays remained same. That means the characteristics of the cathode rays do not depend upon the material of the cathode or do not depend upon the gas which is present in the discharge tube. So we can say the characteristic of cathode rays is independent of the nature of cathode and the nature of gas used in the discharge tube. So this is how the cathode rays were discovered and some of their characteristics were discovered. So what are cathode rays? They are a stream of negatively charged particles which come from cathode and move towards the anode. Cathode is negatively charged, anode is positively charged. These rays are negatively charged. We further confirmed it by applying an electric field, by applying a magnetic field. And they were made of material particles as they rotated the light pedal wheel which was placed in their path. And last of all, their characteristics do not depend upon the nature of the electrode or the nature of the gas used. You change the electrode, you change the gas, but the properties of the cathode rays remained same. In the next session, we'll continue how the name electron was given to the particles of the cathode rays in the next session. Thank you.